Okay, so today we are going to have the second section of limits, second session of limits, sorry. So we have already had one session, and in that session we saw how to do the sums of special series. In today's session, we will be discussing one very famous rule of limits called the Leibniz rule. Now, what is Leibniz rule? You have a definite integral with variable limits. So integral ft dt, but the limits of integration are variable. So the lower limit is h is a function of x, and the upper limit is g, which is a function of x. And you want to differentiate this with respect to x. So the rule by which you differentiate such an integral is called Leibniz rule. So Leibniz rule is a rule which helps you to differentiate a definite integral. So firstly, you start by saying that the integral of ft dt, let it be equal to capital Ft. So you want to do integral of small ft, so let it be equal to capital Ft. You begin like that. So obviously, if this is the case, then on differentiating both sides, ft will be f dash t, right? Small ft will be capital F dash t. Okay, now you use the limit. So lower limit is hx, upper limit is gx of ft dt is capital F gx minus capital F hx. So this is what you will get after applying the limits. Now you do one thing, you differentiate both sides. You do dy dx of the left side and you do dy dx of the right side. So dy dx of the right side will be dy dx of capital F gx minus capital F hx. So ultimately this will be g dash x into f dash gx. This will be h dash x into f dash hx. Why? Because of chain rule. And at this stage you say that since f dash t is ft, so f dash gx will be f gx, and again since f dash t is ft, so f dash hx will be f hx. So this is the Leibniz rule. ddx of ft dt, integral ft dt from hx to gx is g dash x into f gx minus h dash x into f hx. This is called Leibniz rule. Okay. So okay, so let's have a look at one question. Integral e to the power minus x squared dx from 0 to y plus integral sin y dy from 0 to x squared is 0. Integral e to the power minus x squared dx from 0 to y plus integral sin y dy from 0 to x squared is 0. Using this information, the question is that you have to find dy by dx. Okay, this information is given, you have to find dy by dx. So you straight away do differentiation of both sides. You do differentiation of both sides. So dy dx of integral 0 to y e to the power minus x squared dx plus dy dx of 0 to x squared sin y dy. Now you are having a situation where you are differentiating a definite integral with variable limits, so you can apply Leibniz rule. So just see how to apply the rule. So firstly, the derivative of the upper limit, right? So that means derivative of y into whatever is the function value for the upper limit. That means e to the power minus y square plus and of course minus the derivative of the lower limit, but lower limit is 0, so you know that derivative of 0 is 0, so forget about it. Then come to the next one, derivative of the upper limit, so that is 2x, derivative of x square is 2x into whatever is a function value for the upper limit, that means sine x square, and lower limit is 0 and derivative of 0 is 0, so forget it, and right hand side will obviously be 0. So straight away the answer comes dy by dx is minus 2x sine x square by e to the power minus y square. So this will be the value of dy by dx, right? So this is the technique called Leibniz rule, and Leibniz rule has got a lot of relevance in case of solving limits, because you know that in limits we often use L'Hospital's rule. So Leibniz rule is very often used in the sums of L'Hospital's rule, right? So this is the homework I am giving now. So the first question is limit x tends to 0, 0 to x square of cos t square dt by x sin x. This is the first homework question. You have to find limit of 0 to x square cos t square dt by x sin x. This is the first homework question. Question number 2, limit of ft dt from 2 to sec square x by x square minus pi square by 16. And question number 2 has got some options. Question number 1 is a subjective question. Question number 2 has got some options. So these are the options for question number 2. Then we come to question number 3. Question number 3, limit of x tends to 0, sec square t dt 0 to x square by x sin x. Options are 0, 3, 2 and 1. So these are the options for question number 3. Question number 4, limit x tends to 0, 0 to x, y dy by x sin x. And question number 5, limit of x tends to 0, 0 to x square sine root t dt by x cube. Okay, this is question number 5, limit x tends to 0, 0 to x square sine root t dt by x cube. So these are the 5 homework questions, and if you can do these questions by 9 p.m. tomorrow, you can submit it and I will engage you in a meeting and discuss the answers. So that's it for this particular session. Thanks a lot. I'll end this particular session. Thank you. Bye all of you.